Hello, this is Tobert's class. This is lesson number 6. This is chapter 5 and 6, lesson number 6, Mr. Tobert's class. Today, here are my objectives for you to define Newton's second law. We'll review what a Newton is, and there'll be some basic understanding, 3 ideas associated with Newton's second law. And we'll talk about when you change direction, you are accelerating as well. So, Newton's first law says that things ain't going to change unless you do something about that. But now we're talking about Newton's second law. Newton's second law says the amount of acceleration depends on both the force and the mass. The SI unit of force is a Newton, defined by the second law. A Newton is an amount of force to accelerate or move a 1 kilogram object by 1 meter per second. Here are the 3 main ideas related to Newton's second law. Acceleration is the result of unbalanced forces. You must unbalance yourself, Daniel-san. The larger the force makes a proportionally larger acceleration. And acceleration is inversely proportional to mass, which means as one thing goes up, the other comes down. So first, unbalanced forces cause acceleration. Changes in speed, direction, or both. Let's continue. Newton's second law says that acceleration is proportional to the force. So how fast it's moving, or the change in how fast it's moving, is proportional to how much you put behind it. If a force is increased or decreased, acceleration will be increased or decreased by the same factor. If you push harder, it'll change faster. That's what it's saying. The other important factor of the second law is that the acceleration is always in the same direction of the net force. So remember, the net force is the sum of all the forces. So whatever is left, that gives you the net force. So that acceleration will be in whatever is left over in that general direction, be it positive, negative, sideways, whatever. Copy this slide. The greater the mass, the greater the acceleration for a given force. This means acceleration is inversely proportional to mass. The greater the mass, the smaller the acceleration of a given force. So, as the mass gets greater for a given force, it's not going to speed up as fast because it's going to require more force to do that. Acceleration is caused by force and is proportionally to the force and inversely proportional to its mass. This is the relationship between acceleration, force, and mass, where acceleration is A, meters per second, force is in newtons, and mass, of course, is in kilograms. Newton's second law. The acceleration of the mass is in the same direction of the unbalanced net force. Let's get specific. The stronger the force on an object, the greater is the acceleration. If you push it harder, it's going to change its speed faster. Force is directly proportional to acceleration. If twice the force is applied, the acceleration is twice as great. Where on the other hand, if you're messing with the mass now, The greater the mass, the smaller the acceleration for the same amount of force. Mass is inversely related to force. An object with twice the mass will have half the acceleration at the same applied force. Write this into your word maps. The net force is what causes acceleration. There is no acceleration, the force must be zero. If there is acceleration, there must be a net force. The force unit is in newtons and it's based on kilograms, meters, and seconds. These are what I want you to write in your word map. How to solve for acceleration. A equals m divided by mass, where the force is equal to the mass times acceleration, where the mass is equal to the force divided by acceleration. Here's what you should be doing now. Thank you.